Very warm welcome to one and all. I'm Professor M.S. Patil, Department of Mechanical Engineering, Karmavir Advocate Baburao Ganpatrao Thakre, College of Engineering, Nasik, Maharashtra. Today, I'm going to talk about design of machine elements, part 1. Now, what are the learning objectives of this particular lecture? Today, we are going to learn about what is design, what is the definition of the design, what are the various types of design, what is the design process, what are the steps involved in the generalized design process, and what are the different design considerations that are to be considered while designing a machine element. Now, what is design? There are number of definitions given by number of authors related to design, but the most appropriate definition of the design is, it is nothing but it is defined as the use of scientific principles, technical information, and imagination in the description of a machine or a mechanical system to perform specific functions with maximum economy and efficiency. Now, in this definition, there are three things. One is scientific principles, second one is technical information, and third one is the imagination. First, scientific principles. Scientific principles means nothing but the principles which we are using in the basic sciences and engineering, such as Newton's second law, D'Alembert's principle, work energy principle, impulse momentum theorem, then the principles which we are studying in thermal sciences, such as the laws which are related to gases and air, then what we are studying in basic and engineering mathematics and statics. Second thing is related to technical information. Technical information means the designer is having the knowledge of the basic mechanical elements which are used for power transmission, such as belts, ropes, chains, different types of gears, shafts, clutches, brakes, bearings. And third one is the imagination. Imagination is nothing but the creativity with which the designer uses the basic principles of science and the technical information in order to build a machine or a mechanical system in order to perform a specific function with maximum economy and efficiency. Design is highly innovative and iterative process. Basically, there are two traditional methods of design. One is design by craft evolution, and second one is design by drawing. In earlier days, the craftsmen were supposed to manufacture the things or the machines which were useful for them for the day-to-day life, such as bullock carts or the rowing boats. Right? They were manufacturing this type of bullock carts or the boats by mere experience. Right? They were not bothered about the technical know-how, how much material or what type of material is to be used. They were only bothered about the specified function that should be performed by the machine tool they are manufacturing. Now, talking about the bullock cart, right? General materials which were used for manufacturing the bullock carts in those days were wooden, right? But there are other materials also, but they were not using those materials. Right? They were not again bothered about the specific dimensions of the say the sizes of the bullock carts, the size of the wheel, the length, width, and all those things. They were not preparing any kind of drawing for manufacturing the things, and therefore the cost, the weight, the size, it was very much bulky. Nowadays, which we are using is design by drawing. We are talking about the technical equations which are involved in the design of a machine element. For example, we are using the proper process for material selection. We are using proper equations which will exactly define the modes of failures of the mechanical component. And after designing, we are preparing the detailed and assembling drawing of the machine component, and then manufacturing the things. Each method has its own advantages and disadvantage. The disadvantage of design by craft evolution is that the manufactured parts were bulky and cannot be manufactured in mass, right? While in this second method, we can design optimized product and mass production is possible. Now, the typical design process involves this number of steps, starting from market survey to the specifications of product, mechanisms involved, generalized layout, and designing of individual components, and preparing assembly and detailed drawing. First of all, market survey is done in order to identify the need of the component. What is the exact need? What kind of similar products are available in the market? What is their cost? What are their specifications? For all these purposes, market survey is done. Then the other steps are involved in the next, are explained in the next slide. Right. Now, after market survey, we are talking about the product specifications. Right? Product specifications involves the details of the product. For example, if we are talking about the manufacturing of automobile, either a two-wheeler or a four-wheeler, then we have to specify certain specifications of that product. That means whether it is a two-wheeler or a four-wheeler, it is either involving internal combustion engine or electrically operated vehicle, whether if it is involving internal combustion engines, and what kind of fuel it is going to use, either it is a two-wheeler, a petrol engine or diesel engine or a gasoline engine, right? Then we are talking about the dimensions, right? What will be the length, width, height, what will be the shape, how much capacity, how much cc. All these things are nothing but the specifications of the product. After product specifications, we are talking about the selection of mechanisms, right? What are the different mechanisms that should be involved, right? If we are, for example, if we are talking about the braking systems, right? Then braking systems can be merely the linkages which were which are used in the bicycles, right? Or drum brakes or disc brakes. Each one has its advantage, while they are also having certain kind of disadvantages. So according to the need, we can select the appropriate mechanism for the braking system. Now the next step is related to the configuration, layout of configuration and selection of joining details. Now here we are seeing a typical layout of an automobile system. What will be the position of the engine, clutch, transmission, propeller shaft, then it's a differential mechanism, live axle, dead axle, hubs, and all those things. What will be the different joining methods that will be used, right? That is nothing but the layout of configuration. It is a highly creative step. Next step is related to design of individual components, right? After finalizing the layout of configuration, we have to design the individual components. One thing should always be kept in mind: we are not designing a machine as an assembly. We have to design individual components first and then assemble them, right? So design of individual components involved what kind of function it has to perform, what are the different forces acting on them, then determining the dimensions and the geometry of those parts, and then preparing drawings and all those things. After designing of individual components, we are going for preparing assembly and detailed drawing on paper, right? And then preparing the prototypes and testing them for the safety. So this is a typical design process. Then design of individual components. Design of individual components, right? We are earlier we have talked about it, but we will talk in detail over here, right? So what are the steps that are involved in the design of individual components, right? So first we have to specify the function of element and what are the different forces acting, selecting suitable material, determining failure modes, and determining geometric dimensions, modify dimension according to the manufacturing constraint and all those things, then prepare working drawing. We will see all the steps in detail over here. Okay. First thing is to specify the function of the component. Components can be anything. It can be a shaft, it can be a coupling, it can be a key, it can be a bearing, spring, or screw fastenings. For example, if we are talking about a bearing, then we must know what kind of function it has to perform. So bearing, what is the function of bearing? Bearing is nothing but it is a mechanical element which is used to support a rotating shaft. If we are talking about a spring, then spring has different functions in different applications, right? For example, if we are talking about spring, which is used in suspension system, it is going to absorb shocks over there. So these are the functions. We have to specify the function of the mechanical component. The next step is the determination of the forces. If you're talking about spring, then spring is subjected to fluctuating loads. The magnitude and the direction of the forces acting on the spring, which is used in automobile, will have fluctuating loads acting on it. So we are going to prepare the free body diagram of the spring, and we will be showing what kind of forces acting on them. Then third step will be the selection of materials, right? So if you're talking about again the spring, then spring is made up of wire, so ductile material is involved in it. It has to absorb shocks, so toughness is the most important property, stiffness is important property, and resilience, amount of energy stored, is again one of the important property. So if once we have finalized the properties, what are the necessary properties required for that element, then we can select appropriate material depending on its availability and the manufacturing considerations. Now next step is the failure criteria. Machine element is said to be safe if the elastic deflection and general yielding are within certain specified limits. At fracture, if it is a fracture, then we can say that it's a total failure of the material. But if elastic deflection and general yielding, both these things are beyond certain limits, then again we are saying that it is a failure. So if we are talking about spring again, right, then elastic deflection, spring has to absorb shock. So in absorbing shock, it is going to deflect, but after the removal of the forces, it is going to come to its original position. That means elastic deflection is involved. So elastic deflection should be within the certain limits. Then after the failure criteria, we will be using certain equations, right, depending on the type of failure, right? We will be using design equations and calculating the dimensions of that spring, right? And then we will be preparing the drawings, right, testing it, right? And if needed, then we can modify the design if it is supposed to fail. Then we should, as a designer, we should be also familiar with the considerations related to the design. Right? So there are n number of considerations for design considerations. Machine element should be strong enough, it should be rigid, it should be wear resistance. So what exactly is strength, rigidity, and wear resistance? Strength is nothing but it is the ability of the material to withstand external forces without failure. So material should have sufficient amount of strength. It should be rigid in order to resist deformations. Wear resistance is something that is very much important when two elements are in contact with each other. Then we should say that it should be wear resistant. Wear should be as minimum as possible. Then the dimensions and weight. Dimension is something related to the space considerations, right? And weight again is related to dimensions. So minimum dimensions means minimum weight. But when we are talking about minimum dimensions and weight, we should not reduce the strength and rigidity of that mechanical element, machine element. Then manufacturability. Design should be such that it should be manufactured, right? Because there are certain manufacturing considerations also that should be kept in mind. Then talking about next consideration, which is safety. Certain amount of factor of safety should be provided. The machine element which is designed should be safe for its entire life. Conformance to standards. Conformance to standards means, say if we are supposed to design a pressure vessel, then in design of pressure vessels, there are certain standards which should be considered. For example, IS, Indian Bureau of Indian Standards, have specified certain standards in the design of a pressure vessel. Then the design should conform to that standard. Reliability. Reliability is nothing but it is the probability of the machine element that will perform its specified function. So higher reliability means higher factor of safety required. Okay, so reliability is one such thing that should be always kept in mind. Next is next design consideration is maintainability. Maintainability is related to the service conditions. In case of failure of any part in the assembly, then it should be serviced properly and repair time to time. Minimum life cycle cost. The working cost and the running cost of that product should be as minimum as possible. So these are the different design considerations which should be kept in mind while designing a machine elements. That's all for now. Thank you. In the next lecture, we will be talking about the preferred numbers, factor of safety, service factor, and standards that are involved in the design. Thank you very much.